In lesson 14-3, we'll be discussing even and odd functions. So our target today is to recognize when a function or a graph is even or odd. Okay, so we're on page 237 in our Springboard book. You will need some kind of graphing calculator, whether it's your actual calculator or Desmos today, because we are going to be doing a little bit of graphing. So let's go ahead and get started here. So it says the graph of some polynomial functions have special attributes that are determined by the value of the exponents in the polynomial. So we're going to start by looking at these two graphs. So f of x is 3x squared plus 1, and f of x is 2x cubed plus 3x. Now you can just pop those in your calculator or on Desmos and just do a rough sketch of what you've got for those graphs. So go ahead and graph those two graphs here. And we're going to talk about how they look here in a second. So use either your calculator or Desmos, and then just do a rough sketch on your paper. Okay, so if you did it, it should have looked like this. So our first function, 3x squared plus 1, is just a parabola shifted up 1 and more narrow. That cubic function has that kind of swoosh look to it, okay, passing through the origin. So let's look at question 2. It says, describe the symmetry of the graph of 3x squared plus 1. So if you're looking at this graph on the left here, can you figure out, can you say if there's any symmetry going on there? What would you say? Okay. Well, there is some symmetry going on here. It looks like it's kind of cut in half. Let's see if I can draw on here. It looks like it's cut in half right down the middle, right? Your axis of symmetry, if you remember our key terms from Unit 2. So there is some symmetry here. It looks like it's symmetrical of the y-axis. So on the y-axis, we have it kind of being cut in half on both sides. So there's some symmetry going on. Now, question 3, I'm going to skip because I honestly don't see any symmetry there, but we're going to talk about why that is here in a second. So going down here, okay, we have some vocab here. So the function 3x squared is called an even function. So if you notice, every power of x is an even number. Okay, this is true for constant terms as well, since constants can be written technically as the coefficient of x to the 0. If I go back up to this problem, 3x squared plus 1, 1 is a constant, so that technically has an exponent of x to the 0 power, and then we have x squared. So both of those, okay, are even exponents. So we would call that an even function. Okay. The function 2x cubed plus 3x is an odd function. Notice that every power of x is an odd number. So we have x to the third power here and x technically to the first. So we have 3 and 1. Those are both odd numbers. That makes it an odd function. Okay, so that's kind of a property. A function is even if every exponent that it has in the problem is an even number. Something is odd if every exponent in that polynomial is an odd number. Okay, so let's look at a couple pictures here I have. One problem, 1 here. Okay, we can also tell if something is even or odd based on how the graph looks. Okay, even functions will be symmetric about the y-axis. So our y-axis here will always act as our axis of symmetry. And it has to be the y-axis. If it's symmetrical anywhere else, it's not an even function. But it'll be even if it's symmetrical about the y-axis. You'll know if a graph of a function is odd if it's symmetric about the origin, meaning it has to pass through 0, 0. If it doesn't pass through 0, 0, we cannot call it an odd function. Okay, so that's a way visually you can see from a graph if it's even or odd, or from the function itself if something is even or odd, okay, based on the exponents. So I have a couple of examples that go along with that here in this number 2. So determine whether the following function is even, odd, or neither. So let's look at number 1. Okay. This function, it's not even because it's not symmetric about the y-axis. There's not a mirror image. But as you can see, it does pass through the origin. So this graph would be odd. Okay. If I look at number 2, this graph does have some symmetry here. But that symmetry is not the y-axis. So this is a case of a neither graph. And last, if I look at 3, you can see that that has symmetry on both sides. It's a mirror image. And that symmetry is about the y-axis. Okay. So this one is an example of an even graph. Okay, so that's how you can determine if something is even, odd, or neither based on how the graph looks. Okay. Let's move on, though. We're going to kind of skip down here to this check your understanding. Number 6 here, explain why this graph is neither even nor odd. Okay, so to be an even function, every exponent has to be an even number. But if I look at this graph, we have 4x squared. This is technically 8x to the first because there's no power there. We can assume it's a little 1. So in order to be even, every exponent has to be an even number. Well, that's not the case here. We have an even and an odd. In order for a function to be an odd function, every exponent has to be an odd number. So again, we have a 2 and a 1. They're mixed. So anytime your exponents are mixed between even and odd values, that's how you know it's the neither case. Okay, so we're going to look at some problems here on the next slide. I just have a bunch of examples. We're just going to determine if something is even, odd, or neither. So let's look at the first one, x squared plus 4. Remember, a constant term, we technically consider that's x to the 0 power. So if we look at all of our exponents here, we have a 2 and a 0. Those are both even numbers. So this would be an example of an even function. Pen's acting up a little bit today, so our notes are a little sloppy, but that's okay. Okay, if I look at the next one, x cubed plus x, we have x cubed. If we have just a plain x, that's technically like x to the first. So if we look at that, would this be even, odd, or neither? Hopefully you're looking at the exponents. We have an odd number and an odd number. So if they're both odd, this is an example of an odd function. Okay. Let's look at the next two. These are both going to be neithers, and I'm going to explain why here. So here we have x cubed. That's an odd number. Anytime we have a constant, we can technically think of that as like x to the 0. So now we have an odd number and an even number. If they're mixed, that's our neither case. Okay, so this is neither even nor odd. Same thing with this last example here. If we have x squared, this is technically x to the first. And then this would be x to the 0. So our exponents go even, odd, even. So if they're mixed together, that's your neither case. Okay. And I just put some extra graphs on here just to talk about even, odd, or neither again from a graphical part. But if I look at this first graph, there's symmetry. In order for something to be even, though, the symmetry has to be about the y-axis. Well, it looks like that is where our axis of symmetry is. So this would be an example of an even function. Okay. The second graph, the one in the middle here, we can see it does have symmetry. There is your axis of symmetry right down the middle. But that symmetry is not the y-axis. This is in neither case. Okay, and let's look at that last graph. We have a kind of a swooshy graph here. So that's telling me the function could be odd, but in order to be odd, it must pass through the origin, which this one does. So we would say that that is an odd function. Okay, so that's how you can tell if something is even, odd, or neither. So if it's from the polynomial expression, you check at the exponents. To be even, every power has to be even. To be odd, every power has to be odd. If they're mixed, it's neither. Okay, graphically, if it's even, that has to be symmetric about the y-axis. So if you draw a line in the y-axis, it has to be a mirror image on both sides. Okay, in order to be odd, it must pass through the origin. So I'm going to have you guys try some examples here on the lesson practice on the bottom. So 8 and 9. So in number 8, determine whether this function is even, odd, or neither. So we have 2x to the 5th plus 3x cubed plus 7. Is that even, odd, or neither? Okay, the answer for this one is neither. And the reason is because if we look at our exponents, they're mixed. So we have a 5, a 3, Remember, constant terms are technically x to the 0 power. So we have odd, odd, even. So that's a neither case. Okay. So in number 9, determine whether this graph is even, odd, or neither. I'm going to tell you right now that this graph is even. I want you to tell me why it is even. Why is the picture of this function, f of x, why is that an even function? Okay. The reason it's even is because it's symmetric about the y-axis. If you draw a line in here on the y-axis, you have a mirror image on both sides. So it's not just a parabola anymore. This graph has a little bit more to it. But in both sides, it's the same picture. It's cut directly in half down the y-axis. Okay? So that is how you determine if functions are even, odd, or neither.